Well, good afternoon, everyone. Hope you enjoyed lunch, and everyone was able to make it to the pub next door as well. It's so close. So today, I want to talk about composite UIs, and what I think of it as is the microservices last mile. So this is one of those topics I don't hear really talked about a whole lot, and I have a couple of theories behind this. One theory is that I know a lot of companies talk about microservices in terms of the back-end architecture. So we'll have APIs doing different stuff, and it's very self-contained and autonomous and things like that. But when it comes to the front end, I don't see anyone talking about that at all. And I think one of the reasons is that's a lot of companies' secret sauce, like how everything comes together into one single coherent user interface. So I don't see Netflix engineers talking about this. I don't see Amazon engineers talking about this. Facebook talks about it a little bit, but when it comes to that last little part of the user interface, that's the stuff you don't see many open source projects about, many presentations about. So a lot of what this topic is about in this presentation is partly a bit of my experience in building these kinds of applications with these composite user interfaces, things that I've done in the projects for my clients. But it's a little bit of me taking those engineers out to drinks during conferences and then giving them probably more than they should have, and then like nailing them down to the floor and saying, "You got to tell me how you actually built this." And so that's some of what I have in here as well as some secrets I've learned from how Amazon and Netflix build user interfaces, as well as some of my experiences and people I've talked to. So I want to take just a little bit of time to do level set on microservices, because one thing that developers are really good about is agreeing on the definition of things, right? Right? Like REST has a literal PhD dissertation saying exactly what it is, but no one actually agrees about what it is anymore. So that's all our fault, I think. So let's do a little bit of level set to say, what do we mean by microservices? Well, first of all, microservices is not going to be a specific technology or stack. So microservices does not mean Docker, it does not mean Node, it does not mean Azure Service Fabric or whatever thing they decide to come up next. It doesn't mean Lambda functions, it doesn't mean REST. It's none of those things. And in fact, anyone who says so is trying to sell you something. So someone coming to you and saying, "Oh, you're not doing Docker, you're not doing microservices," check to see if they're a Docker consultant. They probably are. So, well, what is a microservice? And unfortunately, it depends on who you ask. So the definition that I try to go from is the microservices book. Now, there's a microservices website and some origin behind the term. So I try as much as possible to go to something that was written down. Well, unfortunately, that definition wasn't too specific either. So from the microservices book by Sam Newman, it says two things. One, it's small and focused on doing one thing well. And the second part is that it's autonomous. The end. So even the microservice definition is micro as well. So looking at the first definition, it's small and focused on doing one thing well. I could argue about any one of those terms about what exactly they mean. Well, what does small mean? Does small mean the number of lines of code? Maybe. I don't know, because I've seen some F# code that is pretty crazy to fit everything on one line. It's all just like weird characters and glyphs and stuff. Or if you have like a Java microservice, it's 99% XML. So who knows what that actually means? What does it mean to be small? Focused on doing one thing. What is one thing? Is it one function? Is it one database table? Is it one controller with one action? There's no real definition here. So what I tend to think in my head of what a microservice is it's something that's small and it's the smallest focused autonomous boundary that we can make. So we're trying to make something as small as possible, that any smaller that we would go, then it will no longer have this property of autonomy. So that brings us to the next definition. What is autonomy? Autonomy has a few different properties. One is independent ownership, availability, and delivery. That means that this thing can live on its own and take care of its own stuff without having to go to anyone else to be able to perform its work. It manages all its own information, so that means it doesn't share anyone else's database. It has its own data that it manages. It can handle any failures related to that service. And finally, it has some contracts about how it talks to the outside world. Now, microservices were originally defined as a contrast to another kind of application, this big bad monolith. And no one wants to have a monolith, right? That seems really bad. And monoliths aren't these things that are the catalyst for human evolution, which is what I gathered was the meaning of this movie. Monoliths are these really big, ugly applications that are just giant, big balls of mud. And so most applications that I work with look something like this. There is the app and the database. And I've actually had companies I work with that call their database the database. Now, again, this works for a lot of companies, right? You can live a long time and have a long life within a company of having an application like this that just serves the entire enterprise. But over time, what happens to this application? It turns into one of these, and usually one of these, like those store procedures that are 10,000 lines long. You have the store procedures that have like 10 levels of nested triggers that like no one knows what the hell's going on, so no one touch it. These applications over time tend to grow with functionality and behavior that they can no longer serve the purpose of everyone trying to use it. So what do? We got to split it up, right? So let's split it up between the front end and the back end. So now we have a front end application picked with whatever SPA technology was the choice of that year, whether it was Backbone 5 years ago or what's today, Vue.js? Is that what we're doing today? I don't even know anymore. I don't try to keep up. But again, what happens over time is I have these single applications, these single layers trying to solve everyone's problem. And again, over time, we run into this now 3 big balls of, I think that's chocolate ice cream, right? So, okay, now we need to split some things up some more. And so what I see most people do when they're building microservice-based architectures is they start to split things up into these individual vertical applications where each vertical application is taking care of every single behavior from the front end to the back end. Almost, but not quite. Instead, what I usually see is something like this, where I have a single monolithic front end talking to a single monolithic, usually API gateway, which I see as like the new BizTalk, it's basically a new BizTalk, but now it's REST instead of whatever it was before. And then that API layer where it's using GraphQL or REST, whatever, that's the thing that's actually talking to the backend services. There's a problem here, right? I've now replaced and made thinner those other pieces, but I still have these really big applications that span every single service. So while the backend services may have independent, isolated features and autonomy between each piece, I still have those big balls of mud all the way at the last mile in the front-end user interface. So this is where I like to roll things back and say, how do people solve this problem when faced with it before computers ever existed? How did people do this 50 years ago, 100 years ago, when they still had all these different isolated pieces? So looking back then, I could see that we would try to have some sort of ideal world. In this ideal world, I would have very independent, isolated groups of people within my company that pretty much worked on their own. And over time, I would build systems and applications for those independent groups of people inside the company. So any company I go to basically works like this, where they have a lot of different applications, but those different applications are really focused within one group or organization inside the company. So I may have a sales organization that has an MVC application and a SQL database. I may have that orders application that is going to be React and MongoDB. I may have the shipping application, but that needs to be used by people actually in the warehouse, so that's going to be a Windows desktop application talking to SQL. And finally, ERP, because its ERP is an AS400 mainframe, and its user interface, I think, is also the AS400 mainframe, usually with varying levels of green and black as a user interface. And the people using each of these applications only ever use those one application. They don't really go from application to application. And any time I need to perform some kind of business activity between those different applications, we have what's known as swivel chair integration. That is, the actual business process is on a piece of paper or notepad that travels from person to person, or what I usually see today, the comments field on some kind of record. You have those comments field where there's like some text there, and then like someone's initials and a date, and like more comments and initials and a date, and that's where the actual business process is. Well, that's because those applications only deal with those one single group inside the company, but we don't have anything that spans across all those different applications. So for these backend kind of services and application, autonomy I find is pretty easy. because those service boundaries that are defining each of those pieces typically follow what's known as Conway's law. This is not Conway Twitty, the country singer with the really weird get-ups. This is Mel Conway, and way in the 60s, he defined this, what he called Conway's law, which is any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. Or what I tend to think of it as, the application a company builds more or less matches the organization structure of that company. For the companies that don't do these big single monoliths, they tend to have applications that just follow the company organization boundaries. And because companies' organizational structures never change, those applications always work, right? No one has a reorg every 2 years, right? That's the enterprise thing to do is, time to do a reorg, we have a new CIO, how else is it going to make his mark other than breaking things up and rearranging the chairs? So for a long time, we can get away with this, that we can have all these independent, isolated applications with these organizational structures that may not change too much over time, and for a long time, this can work. When I'm looking at the arrows between each of these pieces, the communication styles and constraints have not really changed over the years. So I'm looking at two different organizations needing to talk to each other 100 years ago. They may use the same kind of integration methods as they do today. It's just a lot faster than it used to be. So latency has shrunk between all those different disparate applications, but it's still not zero. And as long as we don't make silly or stupid choices where we ignore the fallacies of distributed computing, then everything should just hopefully work. As long as we don't pretend like the speed of light is zero or there's not actually any distance in the Earth between like Hong Kong and the US, we should be able to make good choices about how we build these distributed systems. Okay, I know what you're thinking, right? We're about 10 minutes in and we have yet to talk about any sort of composite UIs. Now, the composite UIs typically don't affect those back-end systems because none of those actually face the customer. So again, this is where I take a step back and say, okay, composite UIs can't be a new problem. It's not something that was just invented by the microservice people. How did we solve this kind of problem 100 years ago? So looking at a normal company that had some kind of customer interaction 100 years ago, the best example I could think of was a department store. This department store is Selfridges, which I think is still a thing, right? It hasn't been bought out multiple times yet and called like Harrods or something like that. So this is Selfridges around, I don't know, the 20s or 30s or something. And inside of there, they had a composite user interface. When you walked into the department store, it looked something like this. Much, much fancier than it is now, but they still have the people that spray the fragrance in your face even though you don't want it. That's still a thing. This is the complete aggregation and composition of all those backend services to provide a singular user experience whose sole goal was to get you to buy stuff. Behind the scenes, there are a ton of different groups and organizational structures to build this composite user experience. There's the shipping department that's making sure that the goods are getting actually into the actual store. They're actually the people that design these front-end experiences. So they're the people that figure out which products need to be put where, which departments should we organize, how should we organize the different floors. Someone's figuring all that out. There's, of course, sales and orders and accounting. All these are things behind the scenes that are not directly exposed to the end user. When you walk in here, you don't know how shipping occurs. You don't know how orders come in. You just come in and see, here's all these products for me to buy. Here's my credit card or whatever, and then you walk out with your product. So if I look how people solve these problems 100 years ago, what I typically find is that the fundamental compositional challenges remain the same. It's just things have gotten a lot faster. We have computers and we have those kinds of systems, but fundamentally, the same division of systems and division of responsibility that existed 100 years ago still exists today. So this is why I think of those compositional UIs as the last mile problem. And I actually looked it up. Like, it's still actually called the last mile problem no matter what the country. It's not called the last kilometer problem. Although I think if Brexit go through, right, you're going to go back to the old units, right? Make the units great again. Isn't that going to happen? So this last mile problem, when we're taking all those services and delivering it to the final end user, this can be the hardest problem to solve. But the last mile is actually the most important part. Because if we didn't deliver that final service to the end user, there would be no business to conduct. So what's the point? If we don't solve that last mile problem, we'll never have the actual revenue and income to build anything in the first place. So we have to solve this problem well if we expect to be able to conduct business in the future. So what might this look like typically? We have all of our back-end services that are doing all their independent things, and then on top of it, we have to put some kind of end-user user interface. The thing that's going to be shown to them that hopefully hides all the complexity and madness of all the services behind the scenes. So from here on out, I want to switch gears and see what are the different options we have to be able to take all these back-end pieces and lift those pieces up into the user interface to have something coherent and cohesive that actually entices them to buy something. Now, I would say like the very first option we should consider is to not compose anything. So what would that actually look like to the end user? And you've probably ran into this in businesses you've worked with. In e-commerce businesses, what this might look like are completely independent applications. And in fact, you've probably gone to a .com website, and you may have noticed that the URL, the domain, actually changed as you went through the website. You started with just the regular store.com website. When you went to the pieces that wanted to sell you something, you may have noticed the URL changed to store or sales.store.com. When you wanted to actually place an order, again, the URL changed to orders.store.com. We wanted to see how to ship something, shipping, and finally, well, probably not ERP because no one knows how to hook up an AS400 to the internet, right? That's not possible yet, hopefully. Each of these different applications has their own independent, isolated database, so we do maintain autonomy. We're not doing cross chit-chat between these services, hopefully. Well, probably so, to be honest. And then the thing we may share between all these different front-end applications that are directly exposed to the end user is maybe just content. Things like common templates, maybe CSS, maybe fonts, maybe images. These would all be served up through this common content delivery network. Now, this gets us quite a bit of the way there. We can share a lot of those assets to make things kind of look the same, but what I typically find is that each of those groups wants to be completely independent about how they design the experience of those applications. And when that's exposed directly to the end user, we know it. We see these like janky websites like, well, the colors are the same, but man, when I went to this part, the menu was up top. When I went to this part, the menu was on the side. Like, shouldn't those people be talking to each other about some coherent user interface? And that's what I find. It can be pretty difficult to fake a composite UI when I have all these disparate applications. The user experience usually suffers. And even before computers, you probably saw this. I especially see it whenever I call into a customer service hotline because something went wrong with an order. And usually in those customer service hotlines, you are directly exposed to the insanity of how their back-end systems work. Like, you'll be transferred from department to department. Yes, my flight is incorrect. I need to book a new flight. Okay, let me transfer you over to claims department. Okay, claims, I don't care about your departments. I just want my flight fixed. Oh, did you buy this via miles and points? Well, I got to go to the remediation department. Okay, so you get transferred again. And transfers, you are directly exposed to whatever kind of back-end systems and departments this company has. And it's not a good experience for you. This is where you usually go on Yelp to complain about things, right? To say, oh, God, their customer service is horrible. I really like the cheap airline fare, but, man, when anything goes wrong, it just goes totally off the rails, and you can't get anything fixed by calling the customer service hotline. So if you don't want that kind of experience where people are leaving you bad reviews on Yelp, then you're going to try to build this one coherent user interface that is able to aggregate all these backend services to provide a single nice user experience for the end user. So once you've swallowed the red pill or blue pill, maybe you just swallow both pills and just take your chances, you figure out that you actually do want to build one of these composite apps. And now comes a challenge. Where are you going to actually compose? How are you going to pull these pieces together? And how are you going to actually deliver it in a meaningful format to the end user? So we have to decide, based on our application, where are we going to compose? Now, unfortunately, I have to say that it depends. And I'm actually legally required to say this as a consultant. It depends, because that's what gets me more contracts and stuff. So it's just something I have to do. That's my consultant's motto. But we have to drive our decisions about how to pull things together based on the application and the user experience we're trying to deliver for the end user. So let's first assume that I'm building a web application, because I already got to say that it also depends on what kind of application you're building. If you're building a thick client desktop application, first say, I'm sorry for you, that's still a horrible experience. It's going to depend highly on those tools and technologies, what's available for you. So let's just assume we're building a web application and see what are the different places that we could have some kind of compositional behavior. Now, ignoring any kind of technology stack whatsoever, I could say that all web applications basically look like this. I've got the initial .com domain entry to the whole system, and then once I'm inside of there is the browser that's going to render HTML to the end user. So that's a place that I can control as a developer to pull things together. Next part is the server. The browser has to call back into something to show and display HTML and JavaScript and all sorts of widgets. So that's another place I can look at to compose in the server. And finally, I can compose at the database level to say maybe this data needs to be composed and aggregated before it's shown to the end user. So I want to look at each of these three areas to look at what are the possibilities for us to compose in each of those areas and figure out, based on the problem space, which of these right areas is correct for us to compose. And again, what I'm really trying to shoot for is I've decided to go microservices, and the whole point of microservices is I can have independent, isolated, autonomous applications or services so that I can build and run different services, upgrade them independently, and not worry about breaking anything else. So I want to make sure that as I'm looking at the compositional areas here, that I'm not reintroducing coupling and making things, again, a big ball of poo or mud or chocolate ice cream. Whatever you want to have it, I don't want to reintroduce that coupling and have another problem in the future. So let's look first at the browser. How can we compose in the browser? Well, we have to start with the user experience. So let's go look at one of the most famous composite UIs that you all probably use on a daily, if not maybe weekly basis, which is, of course, Amazon.com. And I just happened to look at one of the pages in my history. Don't pay any attention to the actual thing I'm looking at here. But when I'm looking at this, I have to decide, how am I going to build this application? How am I going to put everything together? Now, us as developers, we have to have meetings to decide these sort of things. So the first thing we need to decide is what is the front-end UI technology we're going to use to pull all these pieces together. And so this is, of course, a time we need to choose our framework. One of the most exciting discussions we have as developers, right? Like, what is the most up-to-date thing? What is the best thing that's going to look on my CV to make sure that if this all goes up, all goes bad, that I can at least get a job using the thing I'm using to break everything? So we could look at Angular. Angular has a concept of modules and components, so that may be something that we can use to have these independent pieces. React has components. Those are those individual componentized pieces for the screen. Aurelia, which someone told me once is still a thing, has a concept of components. Or you can just pick your favorite noun.js component that has some concept of building independent, isolated pieces to be able to display it on the screen. But there's a problem here. When we decide to pick a single front-end UI technology that everyone is going to need to use, that's actually going to introduce coupling. And frameworks are coupling. We're forcing everyone to use a singular technology that we know is going to change in 6 months, right? Like 6 months from now, there's going to be a new awesome JavaScript framework that everyone should switch to, but we just picked this one, and so now we're stuck. Right? Even if we picked Angular, when we went from 1 to 2 to 3, no, not 3 to 4, was there 5? They just got rid of version numbers. Like, we're not even going to version anymore. You're just going to break you all the time. This is not something we want to force on all the people building these components. We don't want to say, like, oh, man, we really want to move to Angular. Are they going to colors now? Maybe Angular plaid version that has some, like, now they support some new HTML5 stuff that we want to be able to take advantage of, or maybe they support the newest version of ES6, which I think has also moved to color, so there's like ES Red now or something, I don't even know. We want to take advantage of those awesome features, but by forcing us to go on a certain framework, if we want to upgrade, that's going to force everyone in our system to have to upgrade their individual frameworks. there's not really great ways for us to isolate those different pieces from each other. I've seen people try to say like, well, for like one page, we'll have to decide to use a specific version of a framework. And for a different page, you'll have a different version of a different framework, perhaps. So inside those pages, maybe we can agree. But what I typically see is that no one agrees on anything when it comes to JavaScript frameworks. So let's see if we can just get away with not picking a JavaScript framework. I know. So what does that mean? Like has anyone written raw JavaScript in the last 5 years? I have, and it's not too bad anymore. I remember the days that when I was writing a web application, the first thing I did was bring in jQuery because DOM was horrible. Well, it turns out, like with all the work being done with HTML5 and all the new web standards that have come out, that the experience of working just raw HTML and DOM isn't too bad. So I'd go look at it and see, is there some way to package together components in one single widget that it can then easily distribute and push out to the front end? Well, it turns out there is something new, very recent, to be able to do this, and it's known as web components. Now, web components are a very new thing in HTML5. I think the spec is finalized-ish, if anything is ever finalized in HTML5 specs. And if you go look at the browser support for web components, it's basically like Chrome, and that's about it. But there are some ways for us to build web components and have them delivered through polyfills. So we'll look at some tools to be able to do so as well. Now, what web components do is package up all the different pieces that you can have in a snippet of HTML, which would include not just the HTML itself, but it will also include any sort of styling for that individual piece. So again, be careful about styling because styling is global. So you want to pick styling that may not have a global dependency. Maybe it's okay just to have style directly in the HTML, but that's the safest thing to do. In case someone upgrades Bootstrap and breaks everything, that's not something we want to depend on. So CSS may be highly localized to this one individual component. If it's a data-driven component, that HTML may include a template. And with templates, we could just use the JavaScript string stuff that came along. What is it called? The new string stuff. Literals, yes, thank you. Interpolated strings. So yeah, we could use those as a means to provide some kind of templating ability for pushing out data-driven components. And finally, we define an element that says, all these things together can be represented in your actual final HTML as my custom HTML element. So this one, for example, is a custom toggle button that behind the scenes has all of the HTML behaviors and JavaScript and CSS associated with it, but it's delivered to the end browser as this one single HTML element. So we could look on our page and say, okay, right, now that we've got a means to package together these individual pieces, we can break out these screens into the individual components I'd see. So there could be a cart component that would just be like a cart HTML tag on the page. There could be a catalog component for however crazy that thing needs to be. The account component at the top that tells me I'm logged in or not. And the shipping component to tell me how expensive or not the shipping price would be for individual product. Backing all of these individual web components would be some sort of backing services. So the cart component could talk to its own API, the cart API. We'd likely have a front-end, back-end team delivering those two pieces. So the same team that's responsible for delivering the API would be the same team responsible for delivering that final end widget that we see in the screen. And we break up and tie all these different components to the correct back-end services using them, that when we finally get to the front-end interface, we start breaking up all these different pieces into their individual HTML elements. So I have the promos.html, the account HTML, the images HTML, the different formats this thing comes in, and stock and cart over there on the right. The last piece for these HTML components is to actually deliver them to the front-end rendering pipeline so that it actually can go out the door. And this is, again, one of those pieces that no one's really documented well, and everyone has their own kind of way of doing things. But the best way I've seen it is to leverage existing packaging and delivery techniques, things like using NPM. So we could use each individual service team building an NPM module that contains that web component. And then finally, when it comes down to rendering that to the end user, since web components aren't actually supported in all the browsers, we can use a really great tool known as Polymer, from the Polymer project, that's able to render those web components and polyfill them for legacy browsers, or just, not even legacy browsers, just like all of the browsers that don't exactly support this. So the front-end rendering for store.com, they would just have those individual web components on the page, and the back-end service providers would be responsible for defining what those individual widgets look like, the code associated with them, and now the front end is just like basically a template with all these little placeholders that are going to be delivered by these back-end web components. Again, those web components are going to be talking to those individual APIs directly that have those complete autonomous services behind the scenes. This is still like a thing that no one's... I've seen people like talk about it a little bit, but I still don't see like a solid, great example of someone using this in the wild. This again is just what I've heard people kind of talk about, but no one seems to actually have put all the pieces together here. For the most part, what I've seen is people building composite UIs because web components are still very new, that they tend to try to go for server-side rendering. So like Amazon, for example. Like, there's basically no JavaScript on that page. Maybe just like hover things that show reviews, but for the most part, they've kind of given up on browsers because it's like slow and stuff, I guess, and done back-end rendering. Netflix does do some client-side rendering, so they've got like a proprietary version of something like this because, again, they can't rely on everyone having up-to-date browsers because that would just be lost money to them. So hopefully, as web standards improve and as adoption increases, that we can use techniques driven by things like the Polymer project to use these web components to really define these highly componentized pieces that can be still 100% independent from each other. Now, I will say, like, you got to make sure that you draw these boundaries well. If you find yourself having components that talk to each other and have dependencies between their individual pieces, this is reintroducing coupling that we don't want to have. So be really careful about whether you just say we're going to go Angular and do Angular for components or React or whatever. Be really, really careful with explicit dependencies or implicit dependencies between those individual components on the page, and then that's just something they can break in the future. All right, so maybe the browser side composition wasn't right for us. So let's go look to see what we could do on the server side. As unfortunately messy as the front-end side was, the server side is actually a little bit messier. And the reason why is that it's highly dependent on what your server-side stack is. So while the front end, we could say, don't pick Angular because you should never pick Angular. Maybe you go with just React, whatever. Unfortunately, we can't do that on the server side. There's no standard, just completely agnostic server-side framework. Even if we use like middleware between different components, we really have to worry about where on the page we're going to put these pieces together. And that's highly dependent on the server-side stack we have. And even if we pick a single server-side stack, from there we have different areas in that server-side stack that we could actually compose. Most applications today I see are built using Model View Controller, MVC, or should it really be like CMV or MCV? I don't know, seems like the letters are out of order here. But we have some kind of MVC framework typically in charge of actually rendering that HTML to the end user. So even when we pick server, we actually got 3 more choices for how to compose applications. And by the way, if this is making your head hurt, this is why people generally don't try to do this, because again, it's a hard problem that not a lot of people are talking about, but it is definitely a solvable problem. So if we look first here at the model, why would we want to compose at the model side? Well, if I go look at the end user experience, which I should, I want to see what are the reasons why I might need to compose different pieces together into a single model before I give it onto the individual view. Here's a good example of that. In this case, what I have is a search result from the Amazon.com website. So I went and searched just a very popular singer, pop star, and this is one of the first results that popped up. But on this individual result here, I have a lot of different pieces of data coming from a lot of different sources. But it needs to be rendered as a single cohesive element. So I can't really use the same kind of compositional techniques I use on the browser side, because all of the data really comes from needs to come from one cohesive source, so that when it comes to render this HTML, I'm not having to call all these different services when trying to put these pieces together. So ideally, by the time it comes to render the HTML, I've already got all the data I need, and now I'm just concerned with how to format it together to a single end-user experience. So if I looked at the data on the screen, I would need to figure out where all the different data comes from to figure out how should I pull these pieces together to be able to show it to the end-user interface. So in this one single, the cohesive model, which would be like the product search result, the data inside that model would come from a variety of sources. It could come from the product catalog that would contain maybe some product information. Would need to include the price information to say, this is how much it's going to cost you to have to listen to Bieber all the time. It would include ratings for that product, which certainly haven't been pumped up by the record industry whatsoever. I'm sure those are all actually real ratings. And finally, recommendations about if you looked at this product, maybe you would like one of these other products. These are highly disparate data sources behind the scenes that need to come together to this one single model so that when it goes out the door, finally to be rendered at the view, that I don't have to worry about where exactly all this data came from. I've got this single one model to work with. Now, for this part, I actually did talk with an Amazon engineer to figure out how they put these pieces together. And it turns out it was pretty ingenious about how they did it. Unfortunately, no web framework has this kind of composition built in, where I have a single last version of the model. I need to go to a bunch of backend services to pull the pieces together. So you can hard code it, right? I could say in the product search controller, I'm going to explicitly call all these different services and poke in the data all into my model and finally show it to the end user. But that's hard coding a lot of information. If anything changes, whether it's where the service changes or how I need to call the service or where that service is located, I have to go change that controller action. So ideally, if any one of these services changed, then that service team could deliver the new way of doing things without affecting anyone else. So the way I've seen big .com e-commerce websites do it is they do kind of a pipes and filters architecture. That I first start with just basic raw request information, and then I ask all the different services that may match this request information, hey, if you've got any kind of model data that we want to show on the screen, now is your chance. And they're able to handle things like, what if one of these services blows up? Then I just don't want to show that piece of information on the screen. So, like I said, no MVC framework has something like this built in, so this is where we have to put on our architect hat and figure out what abstractions do we need. So one of the things we need is some ability to, based on a specific route information, the ability to say, hey, I can do something with this one. So we might have a very simple interface like this. This actually came from the one of the courses I do here at, so if anyone was in my class the last couple of days, this actually came from it. But it's a very simple interface. It just says, based on the request context, which includes route data, user information, really everything, do you match? And if so, return true. So I could be looking at the query string, I could be looking at the path, I could be looking at cookie data, whatever it might be that could enhance the data that I finally render, I would say, ooh, that's for me, I'll go ahead and render then. Well, the next piece after matching is to actually fill stuff in. And I got to warn you, this is the somewhat ugly part, but I'll tell you why here in a second. We want to have ability to append data to a view model. So we'll have, in this case, a view model appender. The view model appender is also a route interceptor, so it can say, I'm matching something, and then as part of matching something, next we'll say, okay, you've matched, well, go ahead and start appending data to the view model. So I'm able to get that the original request context in to get request data if I need to. And finally, I have something that most C# developers hate, which is the view model as a dynamic, right? Well, when I talk to a lot of people that are doing composite UIs, they're almost always like hipsters using Node and Rails, and those languages are dynamic. They're inherently dynamic. So it's nothing from them to say, yeah, I can just append some more data to this object because, we're hipster developers. We can just do whatever we want. So what I don't want to have happen is to reintroduce coupling by some statically typed view model thing that everyone has to know about. because they would have to know about it at compile time when they're building their component. And again, that's just more coupling that I'm introducing. So I'll use those C# features I usually try to avoid here in the dynamic view model, which behind the scenes is just a fancy dictionary. That's all it is. Just a fancy dictionary that I can I can stuff data into, and it makes it look a little nicer where I'm going. But if you don't like that, they can just use a dictionary instead. This just gives us like a pretend facade over a dictionary that looks something like actual programming, but it's really just a dictionary. So on those search results, I have to implement my view model, my route interceptors. So those route interceptors need to look at request data to figure out, hey, is this something I need to attach to? Now, for normal MVC applications, how do we know how route information is going to attach to some specific executing code? Well, that's the route information, the route data, that MVC just kind of hard codes to say, well, you're going to go to this controller, this action, so you're going to execute this class and this method. But we're throwing that away now. We don't have a controller and action anymore. We just have this kind of loose view model appenders. So we don't have that ability to just use MVC routing anymore to figure out which needs to execute. So the code's going to look a little ugly about explicitly pulling out controller information and action information. So in this case, what I'm looking for is make sure that it's a get method, not a post. Look for the controller value in the route data and make sure it matches orders. And then finally, make sure the route data value includes an ID, that I'm looking for a specific order information. Now, once I've matched a specific request, then my view model appender kicks in to say, now you have the ability to do whatever you want to do. I don't even care. Do whatever you want to do to be able to fill in that information for that individual view model. This piece right here should be delivered by the service delivery team. Not the front-end team, because they don't want to be tied to every single whim of every single service. This is the service delivery team saying, hey, when I need to fill in data, for example, this is order details, I'm going to, in this case, what are we doing? We're calling an API, a REST API, to be able to pull in information. And finally, off of the information we get from that other API, I'm attaching the order number and order items count onto our view model. Now I know, as the author of AutoMapper, I didn't actually show it here, so I won't bore you with those details. You could use this kind of tools, but again, be careful, that's also more coupling. I try to keep these as explicit and obvious as possible, so we're just going to be very explicit about those pieces we're setting. The next appender would be able to attach their own data. So in this case, I have the shipping service that's going to call some shipping API and pull in the shipping information. In this case, it's pulling in the shipping status for your order, as well as the courier associated with it. Now, if you don't want to use REST, you can do really whatever you want here. If you want to use gRPC, because it's a lot lower latency and faster overall, you could certainly do that as well. But your choice to do so is now encapsulated inside of this appender, completely separated from everyone else. If you want to call directly to a database, you can do that. It doesn't affect anyone else in the pipeline of rendering out this view model. Now, I know there are some people in the audience that are looking at us and saying, well, gosh, you're using a dynamic, so you don't have that strongly typed model anymore, so that kind of, you lose some cool points there. And the next piece you have is, well, how do I make sure that two people don't write the same value to the same dynamic object? But it's this thing called Slack. We can actually just ask each other, hey, are we both setting the same value? And usually it's pretty obvious. Sometimes people do namespacing to say, this is the shipping status courier, and the previous one was the orders number item count. So as long as you're not a jerk, then everything should go okay. But we're developers, so there are some jerks out there, I know. I know this whenever I leave my computer unlocked. Some jerk comes by and does something weird. So finally, when it comes time to render the HTML, someone has to be responsible for this. And so I typically see this as kind of a separate team doing this. There is the front-end team that's responsible for that nice, pretty user interface. I don't want orders and shipping teams to be arguing about which needs to go where. Someone needs to be responsible for the final render. And so this would just be one single block of rendering HTML. We get that final composed view model, glom everything together, give it to in this case, this is using Razor templates, and render that one single cohesive block of HTML to the end user. When one of those appenders needs to change, then we just deploy a new version of that appender, the existing UI application wouldn't change whatsoever, and now it will get the updated version of pulling in that data from the outside world, or a different service, that is. So we had to make up that abstraction, unfortunately. There really wasn't a way around it because model composition isn't really a thing in MVC frameworks. It's really just on your own to just make up your own abstraction, but that's what we like to do anyway, right? We like to make up our own abstractions. So it's actually an opportunity to do something that you don't normally get to do or probably shouldn't normally do. Make up our own abstraction for view model composition. Now I'm gonna just completely skip controller composition. That doesn't really do anything. Like the controller for me is just a means of describing an overall route, but otherwise there's nothing else going on. So there's really nothing to show on the controller side for composition. That's not really a thing. So what we'll do is go ahead and skip to view composition. How do we compose different pieces on a screen with a view? Well, you've probably been doing this for a long time. You've been using master pages in ASP.NET, or view templates in ASP.NET MVC and now MVC Core. So for us, we actually already have ways of providing a template on the screen and having individual pieces fill in. Now, that works for like easy scenarios, but what if we have scenarios where the data for each of those different places in the screen needs to come from different places? So over here on my original screen here, I've got a really complex user interface where I have different pieces of the screen coming from different places. I could use view model composition, but that view model would be so wonky with all these different data that had nothing to do with each other. So if I wanted to keep those pieces separate and say, you know what, let's keep like the top widget separate from the side widget, separate from the main widget in the middle, separate from those side widgets. I don't want to glom all these together into a single model that all comes all at once. Instead, I can reach for one of the other lesser used extensions with ASP.NET MVC Core. Now, this extension did exist in old ASP.NET MVC as what was known as child actions. A lot of other MVC frameworks don't have this, as they view them as typically bad because they don't perform well. But in MVC Core, these individual rendering pipelines actually perform really well. And in MVC Core, they're known as view components, something that not a lot of people use. So again, this view component is a replacement for child actions of MVC old, which had a horrible name and didn't actually perform that well. And they encapsulate a single mini request for a section on the screen that includes the invocation of some code, the building of some model, and then finally the rendering of HTML. So I think of it as like a very mini MVC pipeline just for a single section on the page. These view components can have their own parameters to pass in, like here's the order ID that you need to actually render, and their own business logic to do really whatever they want to be able to render that information on the screen. And the way these get invoked is usually from a view inside of your layout. So what does this look like? If I was looking at the stock information widget that shows me if this thing is in stock or not, this is highly specialized to that one answer that I need for the question of is this product SKU in stock or not? I can encapsulate the ability to answer that question inside of my view component. I was waiting for someone to take a picture just to change the slide right then. It was pretty awesome. Anyway, so this is the code for a view component. Notice that it has its own dependencies. I can depend directly on an entity framework DB context, or you can depend directly on a Dapper do, whatever thing is in Dapper is. Or a Petapoco database. Really, whatever this thing needs to do to get the data it needs for rendering, it's 100% encapsulated inside of my view component. The view component has a single method, invoke async, because it's async like everything. That means we have to put async on all of our methods. So invoke async, and this is going to pull into the database, look up the stock for a single SKU, see if it's in stock, and then finally show return a view result that is going to, or view component result, excuse me, for the items that it's pulled out. Now, so this looks very much like a controller in action. That's very deliberate. The only thing that's different is instead of me inheriting from a controller base class, there's a special view component base class that only has the things on it that you should care about if you're just rendering this tiny little widget on a page and nothing else. So trying to keep those two things very, very separate. So inside this mini MVC pipeline, we return a view with a view model, and so that means we need to actually render that HTML on the screen, and so that's what we have here. A tiny little snippet of HTML that's going to render, in this case, a list of stock items that has the HTML necessary to be able to render that stock information out on the screen. Now again, we have to worry about CSS because CSS is global, so we have to worry about the styling of this thing. So we might have those endless discussions about which version of Bootstrap we want. Maybe not Bootstrap, maybe just like one of those layout CSS, and we just do our own thing. That's really up to you. Just keep in mind the coupling side of things, but inside of here, it's just up to us exactly what we want to render here. Finally, when we need to invoke this view component, that's done from the parent view, and it looks something like this, where I say invoke component.invoke async with the name of the component we want to invoke, and then finally the data we want to pass through so that the view component can get that information and be able to render something on the screen. So I'm looking for the stock for a specific SKU, so that's what we pass in the SKU from the parent here. Or there's a new way of doing it that looks something like this, and this starts to look very similar to web components, right? Web components encapsulated the rendering HTML, calling of any kind of backend service to be able to render on the screen. This is the server-side equivalent of that exact pattern we saw on the client side. Now, there is one last piece we need to do here, which is actually package this thing up to deliver to the front-end team to be able to show it on the screen. Unfortunately, there's not a great way of doing this. You can use NuGet packages, or if you're fancy, NuGet packages, to be able to package all these pieces together, to be able to ship to the front-end team. There's not a great way in ASP.NET MVC Core, or most MVC architectures and frameworks I've dealt with, to be able to just kind of pull in other kinds of rendering pieces and other kinds of extension points and be able to just use them immediately. So you'll have to do a bit of playing around to get with the way that would work best for your team. But the general idea is that whatever my delivery method, I want to be able to do as independent as possible from the front-end team. We don't want to introduce yet another bottleneck or set of coupling just because we decided to build these composite UIs. Okay, so we've looked at the browser way of composing applications through web components. We've looked at the server side of composing applications through model-side composition or view-side composition. The last piece is to look at database-level composition. This is probably going to be the scariest part of the talk because this is usually where things can go really, really wrong for your enterprise trying to compose things at the database level. Because that can be introducing another monolithic part of your application. So when I'm talking about database-level composition, I don't mean making the entire system use one single database. What I'm talking about is for a single purpose or a single function or a single part of the page that the only possible way we could serve that function is to pre-aggregate or compose data into a database. So what part of the application that we typically run into would need to have things pre-aggregated or pre-composed in order to provide a coherent user experience? For the systems I run into, that's going to be the search page. The search page pulls in data from a lot of different places in order to perform a coherent search, typically using a bubble diagram. I think it's Elasticsearch. Yeah, Elasticsearch. To be able to provide a search database that is super good at what it does, searching, and be able to show that information on the screen. Now, the reason why we need to pre-aggregate or pre-compose is none of the services that provide this data are particularly good at searching. Like catalogs aren't good at searching, they're good at organizing, but not searching, unless you do like SQL full text search, right? Or just select star from products where named like percent value percent. That performs well, right? Always. No, we put that information inside a tailor-made search database so that this thing could do its job well, which is doing searches and providing relevant information to the end user. But there's a problem in that the data that exists in that search database doesn't actually belong to the search service. So this is an example of a document pulled out of an Elasticsearch database. No, actually, I just made it all up. But you can imagine that it came out of an Elasticsearch database. And it's a document-oriented database, so it's going to be JSON-looking stuff. And everything that's going to search is going to be inside of that document. We can have the ability to also add search indexes for certain kinds of search. We can provide relevancy and ordering to say, these products were always purchased, so bubble them up to the top, and these products were never clicked, so maybe bubble them further down to the bottom. We could prefer certain kinds of fields over the others. That's really what these search databases are about. Again, the problem is, though, looking at this set of data, it doesn't own any of this information on the screen. So like this stuff at the top, the ID, the name of the artist, that's actually from the catalog service. This image URL, that's from the image service, the content delivery network, maybe. Pricing information and the formats it's available in is from the format service. And finally, the review data is from the review service. So all this information that has to be in the search database actually belongs to other services. And so this brings up the data duplication monster. We now have duplicate data from our services duplicated up to the front end, up to the search database. And again, this is where usually DBA is like, oh my God, duplicate data, this is what we want to avoid because now I've got customer data details in 3 databases, and that's bad. Okay, yeah, it's usually bad. Usually in the services I build, I try not to let data leak out of my application into others. I think I heard the quote this morning is that data is the pollution of the 21st century. Because it's easy to create data, it's hard to delete it. And so once my data gets out into the wild, it's very hard to like, oops, actually that's been updated. You need to change it on your site. Oh no. So we have to be very, very careful about this and put it in the most appropriate places. Now, because we're basically required to do this, to duplicate some data into the search database, we have to figure out a good way of doing it. And in fact, one of the engineers that used to work in Microsoft and now works at Salesforce, Pat Helland, had a great paper and presentation talking about this very problem. And his paper was Immutability Changes Everything. And the basic idea is that because data still needs to have a specific owner, it should be okay for me to share that data as long as all the different services that take that data treat it as immutable and read-only and don't ever change it. So as long as my service doesn't decide, oh, the Bieber CD should be $100, not $10, we should be okay. Just honor the immutability of those other pieces. So looking at the ownership here, search owns the shape of the data. It owns the SLA of the response to make sure it's correct and comes back quickly. It owns the relevance to make sure you're looking at which comes first, but it doesn't own actually any of the data behind the scenes. So what we need to do is take all of these services data in whatever way we can get it, feed it into some kind of normal denormalization process, and stuff it into our search database so that by the time the .com website hits that search database, all the data it needs to be able to search is already in there. Now, this is where you can run into a problem in your enterprise because you have to get that data from all those services into your search database, and the enterprise architects may not want you to. So in the immortal words of Dr. Ian Malcolm, life finds a way, or as I think of it, developers find a way. So I have to go to each of those backend services and figure out how can I get that data out, and you have to be creative. So I looked first at the catalog service. The catalog service I know is a known quantity that comes existing as a once-a-day update. So what I'll do is I'll just have some service that calls the API and pulls that information into my search database in one gigantic, gnarly for loop. Just like loop over all the products, call the catalog service, and feed it into my search database. The images service, I go look at the return call from the catalog, and if wait a minute, the image URL is actually already served from the catalog for whatever reason. So instead of me trying to call the image service, I'm just going to go ahead and sever that connection altogether. Just like, sorry, image service, you had your chance. I'm not going to call you. The formats. Now the formats, whether it's a CD or audio, well, I guess basically CD or LP, I guess. This is something that actually rarely changes. Once it's set up once, I never see that change over time. The other thing we found is that this information could be serving many internal clients. So we could just look at how those other existing clients are already doing integration. And so we'll do something like consuming a shared drive of a CSV file once a day. I just happen to talk to the developer and say, ooh, you're actually already pushing out the list of formats on a CSV file once a day? Well, we're just going to call that and call it a day. Finally, the reviews. This one's a more difficult part because that is data that actually changes frequently, and you as a consumer would probably be a little freaked out if you added a review and it didn't show up immediately in the screen. So this is something I need to react to as it happens. So when it happens, I need to make sure I get that information somewhat quickly, update my cache inside my search database, and be able to do the updates. So in this case, I may have to get creative, where I go take the DBA of the review service out for lunch or dinner, buy them a few rounds of bourbon or scotch, whatever they like, and say, hey, would it be cool if you actually maybe put a database trigger in there, and when that database trigger hits, you send us a message and let us know the data's updated, maybe? So yeah, we can use something like messaging to update when that other service changes. So as the database changes, we'll have a hokey database trigger that pushes out a message and pushes that information into our search service. All these different mechanisms are basically integration patterns. So we want to choose, based on those individual services, what is the appropriate integration pattern to use in order to get their information out of their system and into ours. So just to wrap up with some key takeaways. First of all, don't compose unless it's necessary. You probably noticed from this talk that composition is a hard problem. It's been solved by big companies. So maybe you should take a step back before you decide to go down this route. You need to make sure that you don't just choose one compositional model for your entire enterprise. You really want to choose the compositional strategy based on what's best for the user experience for that individual experience. Don't just pick something global for everything. You really need to figure out what is the best solution for any given problem. And again, it depends, right? So we have to make sure we understand the problem. As always, the fallacies of distributed computing are called fallacies for a reason. Don't just pretend they don't exist and build a system that's not actually possible to run in production as opposed to on your local machine. And finally, something to keep in mind is that front ends can become their own individual service boundary with their own data and their own autonomous pieces. So treat them as such as well. So that was Composite UIs, the Microservices Last Mile. I'm Jimmy Bogard. I hope you have a great rest of the conference. Thank you.